All right, let's go and take a look at lesson 2.8. Two 2.8 is about bringing it all together and making sure that we factored completely. So using any of the methods that we've used so far just to make sure that we factored any polynomial that they give us completely. One new concept from 2.8 is factoring by grouping. So if the question says factor, but it gives us four terms, such as x to the third plus 3x squared plus 2x plus 6. Notice that we have four terms this time, right? 1, 2, 3, 4. Terms are separated by a plus sign or a minus sign. So when we have four terms and the question says factor, we're going to separate them into groups of two. So this is called factoring by grouping. This is what we did. We created groups. So out of x to the third, because there's a 1 here, but we don't really need to take out the 1. It doesn't change anything. Out of x to the third and x squared, the x's that they have in common is the lower number out of 3 and 2, so they have x squared in common. Okay, so x to the third divided by x squared is going to be x to the 3 minus 2, which is x to the 1. Then x squared divided by x squared is x to the 2 minus 2, and 2 minus 2 is 0, so x to the 0. So all we'll have is 3x to the 0, but we don't need to write x to the 0 because that just becomes 1, so 3 times 1 is 3. Okay, in this case, we have a 2 and a 6, so we can pull out a 2 because 2 and 6 have a 2 in common, and 2 divided by 2 is 1x, and 6 divided by 2 is 3. Okay, so the ones don't really matter. They are there, but they're hidden, so we can get rid of them, but they are still there. We notice that there's an x plus 3 term and an x plus 3 term. We can combine them and write it like this, okay? Then there's an x squared and a plus 2 on the outside, so let's make sure that we write those in a separate parentheses, and then we'll have a final answer. Okay, let's go ahead and take a look at the next question. Okay, the next question is very similar. It says 2x to the third plus 4x squared plus 3x plus 6. Okay, so again, how many terms are there? Terms are separated by plus signs or minus signs, so there's 1, 2, 3, 4 terms, which means we'll factor them into groups, put them into groups, so groups of 2. Okay, this one has a 2 and a 4, so they have a 2 in common, so we'll pull that out. 2 divided by 2, and also, sorry, there is a x. Both have x's, so we can pull out some x's from them. So x to the third and x to the 2, the lower number is 2, so that this one has that in it, so we can pull out x to the 2. 2 divided by 2 is 1. X to the third divided by x to the 2 is 3 minus 2, so x to the 3 minus 2, which is x to the 1. Okay, 4 divided by 2 is 2. X to the 2 divided by x to the 2 is x to the 2 minus 2, so x to the 0. And x to the 0 is just 1, so 4 times 1 is 2 times 1 is just 2. And then in here, right, they have a 3 and a 6, so the highest number that they have in common is a 3. So if we did 3 divided by 3, we get 1x, and then 6 divided by 3 is 2. Okay, these ones, they're there, but they're hidden. We don't necessarily need to write them. Okay, so what do we see? We see that our groups have the same terms inside of them, so we can write it like this, x plus 2, right? One time. No need to write it more than once. Okay, we can combine them into one. So then the stuff on the outside is going to be 2x squared plus 3. And that's our answer. Okay, so let's say that we have y to the third minus 2y squared equals to 5y. And I'll make this a negative 5y. So it equals to negative 5y plus 10. Okay, so whenever we see an equal sign, that really just means get everything on one side that's a letter. Just get everything on one side. Okay, and then set it equal to 0. Okay, so this negative 5y, because it's minus, we're going to add it onto the side. And notice that we can't combine it with anything because this is a y to the 1, whereas these have a 3 and a 2, so they don't have the same y, right? This is y squared, this is just y to the first, right? This is y cubed, this is just y to the first. So we really can't combine it. And we will also subtract 10 to the other side. And you can't combine that with anything either because that's just a number by itself, okay? So y to the third minus 2y squared. This would be plus 5y, okay, because we added it to the side, right? We moved it by adding it onto the side. And this would be minus 10 because we had to subtract it onto the side. So set this all equal to 0. Okay, so now we see 1, 2, 3, 4 terms. So we'll set them into groups. A group here and a group here. So y to the third and negative 2y to the second. They both have some y's, right? So the highest y that they both have in common is y squared, right? This is the lower number and this one contains that. So y to the 2, we can pull that out of both of them. Y to the 3 divided by y to the 2, and remember this is all division whenever we pull stuff out. It's going to be y to the 3 minus 2, so this would be y to the 1. Negative 2 just stays because we didn't take out anything to affect it. Y to the 2 divided by y to the 2 is going to be y to the 2 minus 2, which is y to the 0. And y to the 0 is just 1, so we would have had negative 2 times 1, which doesn't change anything, right? Out of 5 and negative 10, the highest number that they both have in common that we can divide out of both of them is 5. So let's do that. So 5 divided by 5 is 1. Y stays, okay? Negative 10 divided by 5 is negative 2. And then this is equal to 0, okay? So these ones are there, but they don't really matter, right? They're just hidden. We see that there's same stuff inside of the parentheses, y minus 2, okay? And then the stuff on the outside of the parentheses in front, we can set into another parentheses. And our answer would say y to the 2 plus 5 and y minus 2, okay? Y to the 2 plus 5 times y minus 2. You could set this equal to 0, and you could solve two equations, and we'll go from there.